All right, so hi Ben. Say hi.
Hi, Ben. Hey, Ben.
All right, so this is the Unit 11 pretest. Ben, you did really good. I think you got extra credit. You got more than, I think this is out of 20, I want to say, oh, it was out of 26, but your guys say it's out of, yeah, 29. So I think Ben got 28 out of 26. I don't, it does say that. Okay. Cool. So on number one, finding the area of R, this is just top minus bottom. So that's a problem because top minus bottom changes right here. I guess I can use, I'm not going to use technology. I'm going to go through it fast. Right here it changes because it's two different functions for top minus bottom. All of this stuff is one function. All of this stuff is another function. So to find the area of R, you need to do the integral from 1 to a point that we need to figure out right here. And this is a calculator problem, which means you can actually find it. Everyone found it okay. It was 3.693, something like that. 963, 693. I was just trying to remember it off the top of my head. I don't have anything in front of me.
Yeah, ever since from that self-check thing, I'm starting to put the whole thing. Like, I'm being full on out correct.
All right. Yeah, so 3.693 and then full on thing, I guess, if you want. So that's the bound for the first function, 3.693 of this natural log of x. So this was the natural log of x. And you can take notes on the sides of your test and correct your test as you go along. That's dx, and then that's the first half. The second half is the integral between 3.693 to this 5. You know it's 5 because if I plug in 5 right here, you get a height of 0, and x-intercept of 5 minus x, all of that dx. All right, so I think you got like 1 point for boundaries, if you got the boundaries correct, 1 point for natural log of x and 5 minus x as separate things, and then 1 point actually finding the area. What was the area, someone? 2.986. Okay, so there are 3 points altogether for part A. I'm talking about that to Rochelle since she's correcting her. She didn't want me to correct it. All right, this one was a little bit confusing. Every time that you see a cross section, it would be really cool if you draw a picture, although if you're advanced and you don't need a picture, then don't do it. All right, so this is the square cross section that pops out into the third dimension here, out of the paper right here. What is, I'm going to call this the height of the square. It might be the base, depending on.
It's actually perpendicular to the x-axis.
It is perpendicular to the x-axis, yeah.
Oh, it is. Sorry. I'll say it.
Yeah, if it's perpendicular to the y-axis, then it would be going this direction and then popping out like that. Yeah, it's always good to check that because if it is perpendicular to the y-axis, everything needs to be in terms of y. If it's perpendicular to the x-axis, that's the easy one. They give us functions in terms of x, so that's already ready to go. All right, so what is the height here? Well, the height is just the function. I mean, it was, bless you. The height is y equals ln of x. Height is y. Y is ln of x. So natural log of x is the height. So if I come over here, this is natural log of x. And because this thing is a square where these segments are both congruent to each other, this length over here is also the natural log of x.
See, I didn't think that through.
That's okay. We're working on it. Therefore, if I'm looking at the area is base times height, or just natural log of x, quantity squared.
How do you know which equation to use?
By doing cross sections. Cross sections are the answer.
What?
So I'll show you an example in number 3, part C, where it's just another cross section. It's not a formula that you have to memorize. If you start with the cross section, you will always get it correct. If you start with the area of a circle, you're always going to get it correct if you think about what it's actually asking for. So for this one, there's our area. So I'm going to do the integral. Again, you're going to have two different integrals. Again, 1 to 3.693 of this thing, natural log of x. I was about to point with my finger, but that doesn't really work for you. Natural log of x, that thing squared, dx, because that's the cross section. This is the thickness. Dx right here is the thickness. If I were making it into the third dimension, that would be dx right here. So that's the first half. The second half is, again, 3.693 to 5, and then this entire thing, 5 minus x squared, because that's the cross section again, dx. And I don't remember how to score this thing. If I come back here to the solution guide, zoom in a little bit here. Part B, you get 1 point for the integrand. So if you got the natural log squared, got a point. 5 minus x squared, got a point, and 1 point if you actually got the area of that. Wait,
why do you plus 3 to 5 minus x squared dx?
We need to do both halves. So the first half is this left segment, the second half is that right segment.
Oh, okay.
Both of them still have square cross sections that are popping out into the third dimension. And then the answer here, according to our solution guide, is, do we need an answer? Find the volume of the solid. Why is this not giving us an answer for volume? Don't know what's going on there. Let's go to the actual pause here. Let's go to my key that I made. 2.784. All right, and then coming back again to part C. This guy was hard. There were a few ways to do it. There's Ben's method, and then there's Mr. Sindel's method. Ben's way of doing it was realizing that if there's going to be some line that divides these two segments in half, it's going to be underneath natural log of x. That's kind of straightforward, right? It should be somewhere over there. So Ben's method is basically saying, okay, if you take the integral from 1 to k now, because it's going to be somewhere between 1 and k, then you do natural log of x dx. That should be set equal to half of the volume, or half of the area. We're dealing with area, right? We found the area. The area is 2.986, right? This is equal to 1/2 of 2.986. That's it. And it's pretty straightforward. Ben did not actually do it this way, but this is the way he should have done it. This is the way he was thinking about doing it. He actually set two halves equal to each other, and he might have got points in it, but I realized over the weekend that he got it wrong, at least for either this one or number 3. But yeah, this is as easy as it gets. I think
Why half though? That's what I'm wondering.
so it's saying involving integrals into two regions of equal area.
Oh.
So if those two regions are equal, then they're equal to half of the area that you found in part A. And if you, I mean, technically you'll get full points for this because that's how, I don't even know, does the solution guide say, oh, it does say it that way. So half of 2.986, they did it a different way in terms of y, but it still works in terms of x. Oh, it doesn't work in terms of x. Okay, hold on. This is Ben's method. It would work if it was a line like this, but it's not a line like that. Y equals k is a line like this.
It is.
Yeah. X equals k would have been a line like this. So I apologize. I misled you. That would be totally fine if you were going a line x equals k, but it's y equals k. How the heck do you do that? You could still kind of do it in Ben's method.
Your method doesn't work either because it was x minus or x equals k.
I'll show you that it does work. All right. So let's go ahead and get rid of all that. That doesn't work. Here's the way that you have to think about it. And because I don't have physical paper to rotate 90 degrees, everyone tilt your heads to the right. Look at it like this.
To the left. Oh, because it'd be upside
Because they would be, exactly.
down.
Tilt it to the right so that this is up, this is left, this is
I am
right.
doing it. Yes, I am. Kind of.
You can do it in your mind's eye. You don't actually have to bend your head. It is just easier if you see it. So again, this direction is up, which means if I have this equation, which is 5 minus x, and this equation, which is natural log of x, those are going to have to be transformed so they are actually rotated 90 degrees or rewritten in terms of y. That means if I'm doing top minus bottom, what I'm really doing is I'm doing this function minus this function. And I don't have to have any special boundary in between them because it's always top minus bottom. The top and bottom stay the same throughout the domain of that integral. I don't have any center point here. I don't have to worry about that subdivision, which means even in part A, I could have done it that way. Part A could have been rewritten as top minus bottom as long as you're doing your head to the right thing. So the first thing that I need to do is rewrite these equations so I am actually tilting my head like that. And that's just as easy as rewriting our functions. I used to have y equals 5 minus x. Now I want it x equals something, 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 just using normal algebraic rules. So I'm going to write x equals something down at the bottom. That's what I'm eventually going to get to. So let's isolate that x.
Be negative 5 minus 5, right?
Negative y plus 5.
Negative y plus 5, yeah. It's as simple as subtracting y here and then adding x. So I can add x to both sides, add x to both sides, subtract y, subtract y. These x's cancel out, those y's cancel out, and I'm now left with x equals 5 minus y. Nod our heads. That made sense. I've now rewritten this in terms of y, in terms of saying that this is kind of like the top. That's technically not correct. That's still the right, but it's just rewritten in terms of y, which is the equivalent of tilting your head to the right. Okay, the hard part now is doing this one. Y equals natural log of x. How are we going to undo natural log? Who remembers this from pre-calc / algebra 2?
It's probably E.
It is e.
I don't know what to do with it, but it's probably E.
It's called exponentiation. It's when you say e to the power of natural log of x is equal to e to the power of y. So just write an e underneath there if you're taking your notes. You should know this going into the AP test because it's a useful tool, how to rewrite things, how to undo natural log. By the way, the reason that you do e natural log of something, and it doesn't really matter for us, I'm realizing that it matters more for BC because BC can do log base like 7. If you want to undo log base 7, you do 7 to the power of log base 7 because this base and this, I guess technically also base, are the same base. Well, natural log is log base e, so that's why we're doing e.
E is x.
I think you said it a little bit wrong. So e and natural log cancel each other out, and I now have x. And on the left-hand side, I still have e to the y.
Oh.
And this is really cool too. Like if I come to Desmos, I know it's a little bit of a tangent, but if you don't believe this, it's really cool if you actually see it. So I first have this equation, y equals natural log of x, and it looks like this. What if I now type in x equals x equals e to the power of y? It's the same function. It used to be red, now it's blue. It's the same function, just rewritten in a different form. Pretty cool. Pretty cool. All right, so from here, that's the wrong pen. From here, now I need to do top minus bottom, which is right minus left in this case. So that's going to be 5 minus y minus e to the power of y. This represents the area. I could have written this as the integral up here from 0 to whatever height up here. We found the x-coordinate of this intersection. So this intersection point is 3.693 comma some height that we haven't figured out. You could find that height using that same intersection on your calculator. So we could find that. For now, can we just call it A? I don't know what it is. We know how to find it. We can nod our heads. We're good. We can find that. I'm just going to call it capital A. So if I want to find that area here for part A, I could have done the integral of this guy. I'm going to just copy paste you. Technology. Ha, ha, ha. Technology. It's the integral of that guy dy. Everything is with y. That's a y, that's a y. This is also a dy. Everything is in terms of y, which means these bounds are also in terms of y. Everything is in terms of y. Well, the y coordinate was 0, and then that unknown thing that you could find using your calculator to a. This would have been the answer. Yes.
Actually, what they gave us is y equals k, so it'd be 0 to k.
You already found the answer to part C, exactly. If you come back down here, I'm going to copy paste again. Rochelle is ahead of the game. She's a smart cookie down here. If I come back down here, the answer here is instead of going from 0 to A, change the A, get rid of you, bye, and change it to K. There's your answer. Well, that's the answer because that's half. So you have to say that is equal to half of the area. So 1/2 of the answer that you got up here, 2.986, 2.986. And there is how you do it, looking at it with your head to the right. And if you actually look at the answer, that is exactly what they write in their solution guide. Check that out. It's 5 minus y minus the ey is equal to 1/2 of the 2.986 from the bounds from 0 to k. You literally figured it out just by tilting your head to the right and doing some mathy things. But check it out too. So the way that they say in the solution guide for part A is they can say, oh yeah, you can do it your way, or you could do it this way, which is easier. And by the way, the value of B, they didn't actually, oh, they told us right here. The value is 1.306, 1.307, I guess if you're rounding. Yeah, pretty cool. Questions? It's a very powerful technique and one that I never really went over very well in the last class.
You know what I just realized? So when they tell you like, oh, the horizontal line is, say like y equals k, then you know it has to be dy. But if it says x equals k, then it's going to be dx.
Yes, great insight, yes.
So then would that mean that the equations before, like to find what we'd have to plug in, it would be x equals 5 minus y, or what? Or how would we find them?
How would you find the inverse function, kind of?
Because we're finding y, which is basically what we need. What if it was saying, what if x equals k? Then how would we find the equations to plug in?
then you don't even need to change them. It's the same equations because they're already written in terms of x. And
so then it would just be ln x minus 5 minus x, or would it be the other way around?
so in this problem, you would still have to divide it in half, but using Ben's method of knowing that it's going to be under natural log of x, it would just be, here's the answer for part C. And I wrote it before, it's just the integral. It's going to be under natural log of x. I don't need to worry about that right-hand side. Natural log of x between 1 and a value of k, 1 and k, set that equal to,
It'd be like A, just plugging k instead of 3 point.
and crossing off that second part.
Why?
Because we don't care about where that second part is because we know that the halfway value is going to be somewhere around here. So we don't care about this function 5 minus x. This function 5 minus x, I don't care about him because the value of k is going to be somewhere in this guy.
K is in 3.693, right?
K is going to be beneath or to the left of 3.693. Yeah.
Oh, okay.
So you do 0 to k is equal to 1/2 of 2.986. That would be how you solve if it was a vertical line instead of horizontal. All right, yeah, good questions, good understanding. Let's move on to part 2. So this one was what I would consider to be the easiest of the free response questions. No calculator on this one. What the heck? Is that really called C right here? Did I mess up on my letters?
Nope, it's called A.
It's called A for us. It's just yours is different, remember?
Weird.
Yours is 26, remember?
Don't know what's going on. I don't think that's the reason. I have to go back and figure out what's going on here. Anyway, this is part A. Again, you're doing top minus bottom. How many? Wait, can I just raise hands? Do anyone want to see part A?
I totally missed
I
that.
got one.
Okay, let's do it.
Wait, what'd you get?
I feel bad now saying that it was the easiest problem, but it was
Oh, you did.
generally.
Well, it probably was. I was just like, I give up on this. Let's do something else.
I tried
That's
my
usually
best.
what I do.
Okay.
All right.
I tried my best, but I gave up also.
You gave up halfway.
Equation of the line tangent. That is y minus y1 is equal to m, or you can think of this as f prime of 1/2. F prime of 1/2 times x minus x1, and we know what x1 is. It's 1/2. They gave it to us. This is
Y1 would be 1, right?
y1 would be 1. Yes, it tells us that at the x coordinate 1/2, the y coordinate is 1. So we can fill in the 1 as Rochelle just said. The tricky bit is figuring out the derivative at 1/2. So I look at graph of f, not g. So I'm dealing with f, 8x cubed. I'm taking the derivative. So f prime of x. Multiply down, 3 times 8 is 24, x to the power of 2, and then I plug in 1/2. So f prime of 1/2. 1/2 squared is 1/4 times 24, and that is equal to 6. So the slope here is 6. Done. Scoring yourself. How to score. Let's get rid of that guy. Don't save. Scoring yourself. For part A, you get 1 point if you found f prime of 1/2 if you found 6, and you get 1 point if you filled in the rest of the equation. Preguntas.
I hate this
No, don't hate it. Love it. Love mistakes. Mistakes are how you learn.
Is this like an IQ thing, or is this a like, I don't know. It seems like either you get it or you don't.
I feel like this.
It is
like,
kind of hit or
I
miss.
feel like tests just like they test us on our like common sense.
I
I
feel like this is less common sense than just like, because it's so heavily influenced by, like mood or whatever. Like,
For some people more than others,
I
definitely.
don't know.
Has there been tests shown that people like kids or students are prone to like pass their test with a higher like a better mood, like happy mood or something like that?
Yeah, I mean, they usually break it down by like, did you eat breakfast? If people that eat breakfast are generally better off than those that don't.
Well, it's because people who got more than 2 hours of sleep.
Also, getting like more than 2 hours of sleep helps just a tiny bit. Like 2 hours versus 8 hours. Which one is better? Who knows?
It does, yeah, okay, but I don't know. It feels like such a, it depends on mood and like intuition and not so much on learning, but maybe I'm wrong.
All right, so finding the area. Again, it's top minus bottom. So this top function is going to be our sine of pi x, so that's going to be g. Our bottom is our f, so it's going to be top minus bottom, which is the integral. You could literally write g of x minus f of x, but I'm going to go ahead and write out sine of pi x minus 8x to the power of 3. All of that dx. And our bounds are from, or everything is in terms of x. So I'm looking at the x coordinate. X 0, x is 1/2. So 0 to 1/2.
I have a 0.5. Is that okay?
That's fine, yeah. Okay, so that's the, I mean, it's a little bit tricky setting it up. You might have done 8x to the power of 3 minus sine pi of x. You'll get a negative answer, but you'll realize by the end of that, oh, I just need to switch it, and you can do arrows, and then I think you get points. Like if you just do this, I think you can still get the points for it. Okay, now the hard part is finding the antiderivative and plugging in these values. So antiderivative of sine, anti-sine, anti-same, which means change. So it's going to be a negative what?
Negative cosine.
Negative cosine of pi x. Oh, that's a problem. What's the derivative of the inner? What's dinner?
It's gonna be.
Derivative of pi x.
I would say pi.
Pi. Is pi 1?
Yeah, no.
Pi is not 1. So dinner is not 1, which means we're using Taxman. Yeah, so Taxman really quickly again is you find u, you find your Taxman, you find your u prime. U is pi x, we found that. We know u prime, I just told us, or Rochelle just told us that u prime is pi. What was our Taxman? Taxman was invisible, hiding, ninja Taxman. He's 1, he's out front. So the thing I'm going to be substituting in for the Taxman is 1 over pi, which means our antiderivative is negative cosine of pi x over pi. So that is the antiderivative of the left function. Just getting that one antiderivative right there is 1 point. Gucci? All right, and then we're on to the antiderivative of powerhouse, which is a little bit easier. Antiderivative, I'm going to subtract 1. Sorry, add 1. What am I talking about? Add 1, so x to the power of 4, and divide down. Divide by 4. 8 divided by 4 is negative 2. And that whole thing is going to be evaluation bar 0 to 1/2. All right, so antiderivative, 1 point. Antiderivative, 1 point. Setting up the integral, 1 point. Finding the answer, 1 point. So I think this was out of 4, if that's correct. It was out of 4? Cool. And yeah, I am so far so good, not looking at any notes. I really should have notes printed out, but I'm just so confident. I know what I'm doing.
Doubting. Well, anyway.
And I also keep doubting myself openly. I'm very open with what I'm thinking. So if I'm plugging in 1/2, I'm going to get negative cosine of pi over 2. So pi over 2, if I'm looking at my unit circle, I'll do a tiny little unit circle over here. 0, pi over 2, pi, 3 pi over 2. Cosine is that the x or is that the y? It's the x. Okay, what's the x coordinate at pi over 2? 0. Okay, so this thing is, you're gone. Over pi, you're gone. Don't worry about you. Okay, minus 2 times 1/2 to the power of 4. 2 to the power of 4 is what?
So it's going to be 16 times 16.
So,
16 times 16.
or 2 divided by 16 reduces to 1 over
1.
So this is negative 2 over 16 because of 2 up front, and then Rochelle got the 16 on the bottom. And 2 over 16, divide the top and bottom by 2, you get 1 over.
Oh, 1 over 8.
There it is. So it's a negative 1 over 8. That's the first bit. Now I'm going to subtract that when I plug in 0. So plugging in 0 now. Cosine of 0. Okay, now I'm right here. Cosine of 0. The x coordinate of this point.
What just happened?
Is that a negative 1 over 8? Or is it?
It's a negative 1 over 8. Yep. Super messy. I'm just kind of going fast and furious.
Why are you doing minus 4?
Okay, so what we just did was we plugged in 1/2 into both of these. Chunk chunk. Done. Now we're going to plug in 0 into each of these. Chunk chunk.
So it'd be just, the only thing would be focused on is the cosine thing.
Yeah, because this thing is going to go to 0, so you can go ahead and just put a 0 there. So cosine, when I plug in 0, it's 0 times pi. In here, that's going to be cosine of 0. Cosine of 0 is the x-coordinate of this thing. So the x-coordinate of 0,
That's 0?
x-coordinate of that point on the unit circle. Unit circle means everything is a distance of 1.
1?
1, yep. So this is cosine.
Wait, why is that 1 and not 0?
So it's the x-coordinate of this point. The x-coordinate here is 1, 0. This point is 1, 0. The x-coordinate is 1. So therefore,
Then why is pi over 2 0 then?
because pi over 2 is up here. The x-coordinate up here, so it's 0, 1 for that point. The x-coordinate was 0 for that point.
So if you ever get a cosine of pi something, if it's on the top or bottom, it's always going to be 0?
Yep, and if it's on the right or left, it's going to be 1 or negative 1. If it's some random point, then you have to remember like square root of 2 over 2, which is going to be on the AP test. You do need to know all those special angles like 30, 45, and 60. Okay, so I have a negative sign. Don't forget him. Negative, and then we figured out that cosine of 0 is 1, so negative 1 all over pi. Cool. We have everything filled in. I'm going to rewrite this a little bit neater. Negative 1/8. Double negative. Negative kiss becomes positive plus 1 over pi. Done. There it is. Let's see if we even got it correct. Solution guide number 2. Did we get negative 1/8 plus 1 over pi, negative 1/8 plus 1 over pi? We got it.
So I had a problem.
Yeah.
Sorry, we weren't supposed to use calculators. I used calculator.
Cheater! Cheater! Nope, you don't get points.
I've almost
No,
made
I know
that
that.
mistake, like, a few times.
Yeah, on the actual AP test, it's going to be very, very
Very
clear
obvious. Okay.
because you'll have to break a seal saying you can't use a calculator. So, yeah.
But if I accidentally use a calculator, do I still get that first point from that circle thing?
Nope. Nope, not at all. All right, and it's fine. You're going to get full points after you do the fix-up. On to part C, which is labeled B for mine for some reason. Okay, now we're rotating around a horizontal line, which means if I'm rotating, I'm getting this shape, also known as a circle. A circle's area is pi r squared. I have my phone set to whenever people send me text messages and I don't look at it, it keeps messaging me over and over. Lori gave me a thumbs up. All right. An area of a circle is pi r squared. The trouble here is what is our radius? So our radius is this thing. It's going to be g minus f. So let's say that. So it's going to be pi times g minus f squared. Our radius is g minus f. We know that this distance right here, that is our radius. This radius is g minus f. That height right here is g minus f. We figured that out in part A. So it's pi times g minus f squared, and I essentially just need to slap on an integral here. Remember my dx, and I have my answer. Integral dx, I probably should rewrite what g and f actually are. My integral bounds are in terms of x, so x goes from 0 to 1/2. So this is 0 to 1/2. And if I actually write out what g and f are, I get full points. The way that you would score yourself for shell is, did you get the limits and the constant? Oh my god, I did not get the full points. What did I miss? No, I got it.
Jesus.
I thought I forgot the pi. I always forget the pi. I got it this time. Okay, if you got the pi, the 0 and the 1/2, all of that stuff right there is 1 point.
Wait, what about the minus? Wait, are there minus ones on? Yes, there are minus.
Oh, there are minus ones, yep.
G minus f?
Yeah, so let's back up here. This would be correct if I was rotating around y equals 0, but I'm rotating around y equals 1. So my final answer is 0 to 1/2. I can pop out that pi on the left-hand side. Constants can always come outside of the integral. And then g, what is g? G is sine of pi x. So sine of pi x, all of that minus whatever I'm rotating around. If it's minus a negative, it's a double negative. If it's minus 1, it's just minus 1. That thing. And then I'm going to subtract f. F was 8x cubed minus 1, that thing. And then all of this entire quantity squared dx. And I remember the pi.
Okay, I did not put the entire quantity squared, and you still gave me points.
I did it too quick. I should not have given you points.
Wait, the
Got
whole
it.
thing
I'll be more through on the
squared?
test.
Okay.
The entire, yeah, because it's this entire thing squared. We just forgot to do a minus 1 for each of
Wait,
these.
because isn't it when it's rotated around an axis, it's the individual one squared, or it's the whole thing?
It's the whole thing squared.
I feel like that
Wait, so
changed.
No.
What if we put square on each
Oh,
one?
did it?
Does that still count?
I feel like it's a square on each one.
Yeah,
I
it
feel
is
like
on
it's a
square on each one.
one.
It is.
That's how we're taught.
Oh my gosh.
You're so confusing. Okay.
I am so confusing. Okay, tell me why.
I don't know.
Here.
Okay. Try to explain.
Because
But let's
it's
use
not
the donut.
height times. Yeah. Okay.
Focus on the donut.
It's the donut, the washer, yeah. Because you have one radius minus the other radius, which is really one circle minus the other circle, so they each individually need to be squared. Sorry about that.
Okay. It is easy. Got it.
Oh wait.
I
look
feel
at-
bad.
Okay. Okay. So for what you have, it's like you use G minus F. And look at your answer. Look at the answer sheet.
Mm-hmm.
They did that.
Yeah, it's the same thing. It'll come out. Oh, is it? What's the outside? Outside is G. Huh? Why did the answer key put F?
I don't know. That's what I did.
Oh, okay, yeah. So extra credit point if someone can tell me why.
It's on the outside because 1 is above.
Yeah, exactly. And she doesn't even log it. Yeah, if we were doing this line, then it's F on the outside, then G. Yeah, and that does matter.
You weren't able to use that extra
Of
credit.
course I'm not gonna. Okay, you know what?
Yeah, you should let me say it.
So what if I should have?
So those do need
I
to be
need
switched.
extra credit.
Man,
Well,
so many errors. I can just imagine Ben yelling at his computer, that's wrong, give me the extra credit!
Wait, Mr. Sindel,
Yeah.
I have a question. On the answer sheet, they put 1 minus the.
Oh yeah, it totally doesn't matter.
It doesn't matter?
Because it's going to be squared. That represents a number, right?
Yeah.
Number squared is always going to be positive, so it doesn't matter the order in which you do it.
Oh, okay. Yes. I got it right.
Cool. Yep, how you score yourself. Oop. Well, that's gone anyway. Let's go to number 3. This is the hardest problem on the test. If you're doing John's original curriculum, part C, he changed it to a square. I left it as a rectangle to let you play with a rectangle. The test will not have any rectangles. The test is only squares. Just as a heads up. But I do want to expose you to it because I want to show you what the AP offers. Yeah.
Sorry. Look at your answer sheet.
For
C.
I have to open it again. File, open recent, pretest solution guide number 2. Yeah.
So the limit's a constant. That would be pi and integral of 0 to 1 over 2, right?
Those two. Yep.
Okay. So look at your.
And the integrand is the rest of that. So that's 1 point if you got that squared, 1 point if you got that squared. Mr. Stendhal would have got 0 out of 3 for that answer key. This is why you need the answers in front of you. All right. Don't save. Go away. All right. So finally, part number 3. Did everyone get full points on A?
No.
No? Okay, let's do this one.
Okay, and I
Wait,
have a
what was
question
A?
on it,
Stop.
I think.
I can't really say anything, so.
It's this one right here.
No, I don't really answer.
Oh, that's right. I do have to go through it for Rochelle. All right. So find the area R. R, this is 2 square root of x. This is the line 6. So top minus bottom is just 6 minus 2 square root of x. Slap on an integral there. Our bounds in terms of x, because I have an x right here. So from 0 to 9, that thing dx. That's just top minus bottom. Make sure you get the bounds correct. How to score yourself for that one? Oh, you actually need to find the area. I forgot to actually do that. Now I need to take the antiderivative. Antiderivative of 6 is 6x, right? This 2 square root of x is 2x to the 1/2. So if I'm taking the antiderivative, I add 1. 1/2 plus 1 is 3/2. So x to the 3/2. And divide down, which is multiplying by 2/3. What's 2 times 2/3? It is indeed 4 over 3. Okay, that is going to be evaluation bar 0 to 9. So far, so good? When I plug in 0, don't got to worry about it. Both of them are going to be 0. All I have to worry about is 9. I decoded your message. I remember doing that one on
Oh,
here.
yeah. Well, because I knew that I wouldn't remember to ask about this thing that's super confusing, and I forgot that you can read that. So.
Yeah, I had to break out my old memory, I guess.
Anyway,
So when I plug in 9, I get 6 times 9. I'm just going to write 54. Minus, and then 4/3 of 9 to the 3/2. How do I do 9 to 3/2? As a bit of review, this guy is going to be square root of 9 to the power of 3, because 1/2 is 9. That was a horrible explanation. This is also 9 to the power of 1/2 to the power of 3, because 3 times 1/2 is 3/2. So 9 to the 1/2 is 9 as a square root. Square root of 9 is 3. 3 to the power of 3 is 27. This thing evaluates to 27. All of these branches are equivalent. So it's 54 minus 4/3 of 27. 27 divided by 3 is 9. 9 times 4 is 36. So 36, 54. 4, and I get the 18.
Yeah.
Cool. Is that what they got? Yay! All right. So 1 point for the integrand, which means 1 point for that inside part, 1 point for the antiderivative, and 1 point for the answer.
But here's the thing, though, for me. I didn't put 6x. I just put 6, and that long line from 0 to 9.
Yeah, you don't get the point then for the antiderivative. Did you get 18?
Yeah.
You get a point for the answer. You just don't get a point for the antiderivative.
What about the derivative? Like,
Did you write this thing right here? 6 minus 2 squared of x? You get a point? Yeah, so you got 2 out of 3. All right, on to part B. We have 6 more minutes left for class. I really want to talk about C in depth, so let's go through this one quickly. Rotate around y equals 7, so I just need to subtract. So it's 6 minus 7, that thing squared, minus 2 square root of x minus 7. Oh, did I write those in reverse order? I did, dang it. Okay, the line was up here, which means the outer function is actually square root of x, so I need to reverse these two. Oops.
What's wrong with you?
I don't know. I'm just going too fast. I'm too crazy today.
Hey, don't forget the pi.
Don't forget the pi. Valuation from 0 to 9. Don't forget a dx in there. Probably need some brackets to let you know you're multiplying all those by dx. And I
That's the answer.
think that's the answer. Let's check. How do we do? Yeah, they do it backwards. That's okay. Squared, 0 to 9. Yeah, so we get 1 point for 7 minus 2 squared of x squared, 1 point for 7 minus 6 squared, and 1 point for the 0 to 9 and pi. All right. Questions on B? All right, we did B in 1 minute, which means we have 5 minutes for part C, which was the hardest problem on the entire test. All right, so we have a rectangle, which we've never seen before. That's the reason it's hard. I mean, if you know how to do this, it's probably
You did warn us about the rectangle.
I did, yeah. All right, so the base. This base right here is this height right here. The base, and then it pops out in the third dimension, yeah?
Okay.
Can we all visualize what's happening? Okay, so I need to figure out what that base is. Well, the base is just 6 minus 2 squared of x. Can we all agree that this length right here is 6 minus 2 squared of x is what we wrote right here? Let's write that on our cross-section. So our cross-section here, our cross-section right here is 6 minus 2 square root of x. But I don't know my height. I did write that, okay. I don't know my height. It says our height is 3 times the length of its base. Well, I just take that and multiply it by 3. So 3 times 6 minus 2 squared of x. There is the cross-section, which means to find the area, I need to multiply this all together. And because I don't have to evaluate, it says do not evaluate, I can just leave this garbage junk and multiply it all together. So here we go. The area here, this area that I ran out of room for the rectangle is 6 minus 2 square root of x. Oh, I can actually simplify it a little bit nicer. I could just rewrite times 3 times 6 minus square root of x, but I can really just write times 3 and then put a square on that one. Nice. You're efficient about that. So that represents the area of the rectangle. And that was the hardest part about this because we've never seen that before. And now I need to slap on an integral there, make sure I do everything else correct. So integral, I can even pull that 3 to the outside if I want. 6 minus 2 square root of x, all of that quantity squared, dx, evaluation bar between 0 and 9. Our bounds are 0 to 9. And I think that is it. Yeah, let's.
That was it. I'm so mad.
You might be so mad.
It was like I didn't do anything. I didn't understand it.
Why do they rewrite it in terms of y?
So the way it's written, doesn't it imply that both? No, wait. Because how is the 3? No, never mind. Okay.
Oh, okay. I see why it was hard now.
Why?
I think. Wait. Ah, this is the reason why it was freaking hard. Boom. Check that out. I've just boxed it. Perpendicular to the y-axis.
No.
What does that mean? Tell me. This is what we just did is perpendicular to the x-axis,
So we need to do perpendicular to the y-axis.
which means every single thing needs to be written in terms of,
Y.
Or X.
again,
Oh, because it even says there 0 is less than or equal to y.
I mean, it does. I mean, the main thing is wherever it says perpendicular. If it says perpendicular, that's what you want to pay attention. Perpendicular to the y-axis, everything needs to be rewritten
But
in
then
terms
also
of
think
y.
about it. We did the integral of 0 to 6. It's supposed to be 0 to 6, right?
Yeah, I mean, this is still correct because that's in terms of y. So 0 to 9 are the bounds for x. It's just that's still a problem because that's written not perpendicular to what we want. Computer, grab the correct things. Ah. All right, we only have a minute and 20 seconds. Let's see how fast I can do this. If my computer would even respond, why?
Now you're not gonna finish it.
All right, I am gonna go ahead and do this. Okay, so I need to rewrite this equation as, so it was 2, y equals 2 square root of x.
Wait, so you have to erase everything?
Yep. I have to undo it. So it's going to be y over 2 is equal to square root of x, which means x is equal to y over 2 quantity squared, which is the same thing as y squared over 4. That is the thing we're talking about, y squared over 4. That is the base. Sorry. Yes, that is now the base of my rectangle. My rectangle has a base of y squared over 4, 3y squared over 4. The area is now 3y fourth over 16. Then you slap on an integral there, do a dy, and we need, what are our bounds here? Our bounds are going to be a little bit tricky. Our bounds are going to be from 0 to the y coordinate, which is 6. So from 0 to 6, and I think that's the answer. So 0, 6, 3 over 16, y to the fourth. Boom, there it is. Same technique, just rewritten in terms of y. And yeah, you have to really be careful. If it says perpendicular to the y versus x, it is an entirely different problem. All right, questions? All right, I can go over multiple choice more tomorrow.